Hello, everyone. Welcome to Fabric Espresso series about data engineering and data science. My name is Estera, and today I'm joined by Santosh, and we are going to talk about Spark Compute for Fabric. We will learn about Spark Compute capabilities for data engineering and data science workloads, which includes started pools and custom pools. Santosh, thank you for being here today.
I'm super excited to join you, Esther. Hi, all.
Hey, can you start with the brief introduction of what you are working on right now?
Totally, yes. Part of the Fabric Spark PM team. I lead the Fabric Spark Compute, and which we'll be diving deep in today's episode. Along with that, I also work on other Fabric enterprise platform capabilities and settings.
Super. So let's jump to the topic of the session. Can you start with a brief overview, introduction, what Spark Compute is in Microsoft Fabric?
Sure, yes. So Spark Compute is one of the most powerful distributed analytics platform that Fabric offers. And in this case, there are different types of Spark Compute. By default, users would be already provisioned with Spark clusters, which are always available through starter pools. This is the default option, so users don't have to create clusters or manage them at any point in time. They could if they would want to, they don't have to. And that's through custom pools where users have all the flexibility to customize these compute options and define the type of Spark workload that they would want to run on. And all of this compute is managed by the platform. And it also allows users to perform data engineering operations, transformations, and run machine learning models and train them, everything within their Fabric workspace.
Can you just summarize what is the difference between Spark Compute in Fabric versus Spark Compute in Synapse? Because I believe that majority of our viewers are pretty familiar with what we right now are serving as Synapse Spark.
Totally, yes. That's a very valid question. So the custom pools that you see as an option in Fabric are no different from the pools that we offer in Synapse. So those are the Spark pools which users will be able to create. But those are for users who are familiar with how Spark works and the type of compute that they would need. For business users, Fabric creates a differentiator in the space by by abstracting all of these compute concepts. All users would have to do is start a Fabric workspace, create a notebook, and they already have a compute available in their workspace to run their jobs. And that's powered through the default option that's startup pools. And one key differentiator that I want to call out in Fabric is the instant run experience that Fabric offers. Users will be able to get Fabric Spark sessions within 5 seconds, which is the fastest, which is 36 times faster than what users would experience in Synapse or any other analytics platform.
Normally, Spark session is starting within 3 minutes, 3.5 of the minutes every time we are running a new Spark session. So it sounds that in Microsoft Fabric, it's just 5 seconds, right?
Yes.
Insane. Super. Can you walk us through the process of setting up, configuring, or just show us the Spark Compute inside Microsoft Fabric?
Totally. Would love to. So let's first start with the default option. That's the starter pools. So these starter pools are pre-hydrated clusters that provide the 5 second session start experience, as you mentioned. These are managed by the Fabric platform for users. So they don't have to worry about creating them or making sure that they are available when they are during the time of job submission or any of that sort of management. All they would need is just a Fabric workspace and associated with the Fabric capacity. And as soon as the jobs are submitted, these pools would get the job requests and start executing them. These pools are defined with a configuration of medium-sized nodes by default, they all have auto scale enabled and also are enabled with dynamic allocation. And they start from a minimum node configuration of one node, and they could scale up to like 10 nodes. In the coming months, the startup pools will automatically be resized based on the customer's purchase capacity. And this is something that's the maximum nodes configuration of like which is set to 10 is offered as a preview experience. And also in the coming months, workspace admins would also be able to configure the number of max nodes that they would want to set their starter pools to. They could set it to 2 if they would want, or they could also go all the way up to 100 if they have enough capacity. Now, let me actually walk you through the demo of starter pools and the blazing fast performance that it gives for all of Fabric data engineering, data science workloads. So when a user creates a Fabric workspace, through workspace settings, users would be able to explore the compute option. By default, a workspace is provisioned with starter pools, as you can see here, which is configured with medium nodes. Now let's go and see how fast we get a Spark session with starter pools. I have a notebook that is now configured with the default configuration of starter pools, and you can see that I'm able to get the Spark session started up within 5 to 10 seconds. And you can see that the Spark session is already live, and I didn't have to go and configure or specify any of the settings to get started.
You mentioned that changing the size of the machine is coming soon.
Yes, it is not there yet, but it is something that we are planning to roll it out as we enable billing in few months. In this case, the customers will be getting their starter pools sized according to their Fabric capacity.
Super. Now I'm really wondering, what are the custom pools?
Custom pools are no different compared to like the existing Spark cluster experience or Spark pool experience that we have in Synapse. So custom pools will allow users to configure their Spark sessions based on their workload requirements. They would have the standard compute options, node family, node size, auto scale features, and dynamic allocation, where they would be able to set the min and max executors, and the platform manages to dynamically allocate the executors so that they get the optimal run experience. And these pools could be created at the workspace level by workspace admins. And once the pools have been set as a default pool option for the workspace, users would be able to use these for their notebook and Spark job definitions within the Fabric workspace. These clusters would take up 3 to 5 minutes for session start, unlike starter pools, which would give you the 5-second session start experience. But in this case, users would be able to size their machines based on their available capacity. So they could go with a small compute, or they could also with an XX large type of machine. I would also want to walk you through how users could go and configure these and get these set up as part of their workspace. So when a user lands on a Fabric capacity, users would be able to set up their workspace. And once they have a workspace ready, users would be able to navigate into their workspace settings and select the Spark compute option under the data engineering and science settings. Here, you can see that I already have a compute. Now, users would go into this drop down and they would be able to select a new pool option. So this new pool is going to be a custom pool. So users would be able to give a name for the pool and specify the type of node size. In this case, I want to go for small. And the other interesting option is with Fabric, we would also allow users to configure a cluster with single node. In this case, and this has been one of the most asked feature for like existing Synapse users. So when I'm setting it to just one, if I turn off auto scale, I would just be able to set it to just one in this case, and which would allow users to run both drivers and all of the executor in just one single machine. But users in this case, if they have more capacity, they can go all the way up to, say, in my scenario, I'm going to like 32 nodes, but it's sized based on the available cores that's available in a capacity for a customer. Once the user sets these configurations, users will be able to save these as part of the settings. Once they save it, all they have to do is they could start running their workloads. They can run their notebook jobs, they could run their Spark job definitions, and all of it is not going to be using my custom pool, which is a small compute size, but has up to like 32 nodes, which it could auto scale up to. I did also mention about the support for single node.
What is the unique value? What are the reasons why customers are asking for a single node, knowing that the Apache Spark by nature is taking the data, distributing the data, splitting the data into the number of nodes which are available and playing in the role of workers. And then every worker is doing the specific task, executing the query. At the end, the Apache Spark is merging the results, and the result is that basically the query is running faster. So I'm wondering, what is the unique value of a single node?
That's a very valid question. And yes, you're right. Spark is meant for big data. And the distributed query processing and performance is the big winner advantage why any enterprise user would want to choose Spark. But there are also other scenarios where if you're running a small ad hoc analysis, or if your capacity is used only for like trying out smaller workloads, which do not require larger machines, and your data volumes are smaller, then in that case we want to give customers the flexibility so they could optimize on their compute usage. They could go with a single node machine, and they could still have higher job reliability. So as part of the single node support, we not only support like users to configure it to one node, but we also provide restorable HA, in which case users, when they're running jobs, if they run into node failures, they run into session errors, we would still be able to restore the session so that they don't lose progress, which is a huge differentiator and also allows customers to have an option for a cost-effective configuration, or even save upon compute capacity when they are experiencing peak usage hours and not be blocked or throttled by other workloads in an enterprise scenario.
Now I'm thinking that a single node is a perfect match for all Pandas users. There is a well-known issue, thread, when I should use, as a data scientist or also as a data engineer, if I should use Spark, so PySpark, assuming that as a user I'm just programming in Python, or maybe Pandas. Pandas is easier to just to use because of the syntax of the library. At the same time,
totally.
Pandas is not understanding the Spark architecture, so basically it's just one node processing data processing library. I know that like some time ago, Databricks was working on Koala's library.
Exactly.
That was basically bringing Pandas API on Spark, and the Koalas has been merged into the just Spark, and it's available. You can use Pandas API on Spark, but still it's not the same as Pandas per se. So would you recommend for Pandas users to use a single node cluster?
Totally, yes, and this would be most usable compute option without like spending too much on compute for data science workloads, especially during the initial stages of model development or exploratory data analysis, where all your workloads are heavy on pandas and don't require this distributed query processing capabilities where you would need larger machines or like more nodes. So yeah, totally. This has been one of the major asks from existing Synapse customers, and I'm excited that we're able to get this enabled as part of Fabric.
Good. Santosh, thank you so much. It's really a deep dive into the understanding of Spark compute capabilities in Microsoft Fabric. It sounds that it's more a liberal approach, meaning that as a user, I have Spark compute for me, working for me, zero configuration required. But at the same time, I'm able to customize the Spark compute using the custom pool approach. And at the same time, as a data scientist or data engineer who is using Pandas, I have something what is meeting my needs, and I do not overspend on multiple nodes, which for Pandas are not working.
Totally, you're spot on.
So my last question would be, for those who are new in this area, what would you recommend to reach, view, or are there any materials? How to start to be on top of the all announcements related with Spark Compute in Fabric?
Good question in this case. So we have all the documents published as part of our Fabric documents. So users will be able to access the Spark Compute configuration, get an overview of all the compute concepts that we went through now, and understand what are the different SKU size, how they could configure, and how they could also manage their custom pools, and also how much of these would account towards their capacity. So all of these details are published and they could be accessible in the Fabric Docs link. And in terms of announcements or like features, of course, we will be updating them as part of blog announcements, where users will be able to understand if there are new options coming up or new control or settings for them to manage these properties.
Super. Thank you so much for being here and sharing all the deep insights as you are part of the Fabric product group at Microsoft. And thank you all for watching this episode. For the next episode, Santosh is going to join me again to discuss some very hot topic, that is high concurrency mode in Microsoft Fabric. So again, if you like the video, please the like button, leave the comment, leave the question, and see you next time during the next episode. Thank you so much.
Thanks all.